What is it?
I've completed a sketch of my species theory. I believe it's a considerable step in science. If anything should happen to me...
What do you mean?
If I should die...
Die? Charles, for goodness sake.
Please, my love, it's important. If anything should happen to me, I'd like you to see to it that it gets published. £400 should be enough to see it printed and promoted.
Nothing's going to happen to you.
You say here that the human eye may possibly have been acquired by gradual selection of slight, but in each case useful deviations.
Yes?
That's a very great assumption, Charles.
Well, if I'm wrong about that, I'm wrong about everything. My entire theory's in ruins.
Can your theory account for the way my eyes and ears and hands and heart combine to reproduce the sounds that Chopin heard in his head? Isn't that a God-given gift?
Well, it's given, but not, I think, by God.
You're a man of science. You don't want to believe anything until it's proved. But some things are beyond proof. It would be a nightmare to me if I thought we didn't belong to each other forever in heaven.
Emma was a sincere believer in the Christian plan of salvation, and that those who trusted in Jesus and his resurrection from the dead would spend eternity in heaven. She saw that her husband's speculations about the origins of species and of humanity would jeopardize the Christian plan of salvation. God was being made remote in her husband's universe. Now, if nature by itself, unaided by God, could make an eye, then what else couldn't nature do? Nature could do anything. It could make everything.
In Darwin's day, the very existence of an organ of extreme perfection like the eye was taken by many as proof of God, as proof of a designer. How else could all of the intricate organs and substructures of the eye have come together in just the right way to make vision so possible and so perfect? But it turns out the eye isn't exactly perfect after all. In fact, the eye contains profound optical imperfections, and those imperfections are proof, in a sense, of the evolutionary ancestry of the eye.
Eyes are imperfect because evolution does not create things the way a designer or an artist does. Natural selection simply favors random changes that make an organism more fit to survive. And imperfections in design often result from evolution's constant tinkering. One such imperfection proved traumatic for artist Valerie Young.
We had just come home from a party, and I saw a lot of lights flashing inside my eye, especially on the outside edge of the right eye. And I thought we may be in trouble here. And it took me a while to really see that this was coming from inside my eye. Luckily, my husband was with me because I wouldn't have been able to drive to the hospital. So my vision was pretty obscured. The only way I can describe it is like a jellyfish with lots of little bubbles in it. And it just kept turning and floating in front of my eyes.
Valerie had a retinal tear, not an uncommon problem due to the way human eyes evolved from light-sensing patches of brain tissue in our ancient ancestors. In the human embryo, eyes develop from bulges in the brain's neural tube that pinch in to form cavities. This top layer, the retina, which tore in Valerie Young's eye, contains cells that collect light. It rests against a second, darker layer that lines the back of the eye, but the two layers are not attached to one another. And when the jelly that fills the eye liquefies as we age, it can cause the retina to tear. The jelly can then seep into the space underneath, leading to a retinal detachment and in some cases, blindness.
When Valerie Young came in, her floaters were an immediate clue that she could have a retinal tear. We were able to successfully apply laser treatment in the office that day to seal it off, like applying sandbags around something, to wall it off so that the vitreous jelly would not get in the break and detach her retina.
Valerie Young's retinal tear is just one example of imperfections in the design of human eyes. Another occurs because nerve cells and blood vessels evolved to lie in front of the retina, where they interfere with its ability to form sharp images. It's like trying to take a picture through a foggy piece of glass. And the optic nerve itself evolved to connect to the brain through a hole in the retina. So the eyes of all vertebrates have a small blind spot right near the middle of the visual field.
Evolution starts with what's already there, tinkers with it, and modifies it, but can never do a grand redesign. So even the eye, with all of its optical perfection, has clues to the fact that its origin is of the blind process of natural selection.
Darwin believed that what he called an organ of extreme complexity, like the eye, could evolve by small steps, given enough time. Any trait that improved vision would aid in the search for food, or a mate, or in the avoidance of predators. So natural selection would most certainly favor those traits.
And what Darwin was able to do was to point out that you might think in logic that it's difficult to imagine a set of intermediary stages between the simplest little spot of nerve cells that can perceive light to a lens-forming eye that makes complex images. But in fact, these intermediary forms do exist in nature.
At the University of Lund in Sweden, zoologist Dan Erik Nilsson has developed models to show how a primitive eye spot could evolve through intermediate stages to become a complex human-like eye in less than 500,000 years.
Yeah, I've been interested in eye evolution for a long time. And in particular, I've been interested in the question of how long time it would take for an eye to evolve.
Nilsson envisioned a sequence of stages by which a flat patch of light-sensitive cells on an animal's skin could evolve into a camera-type eye. As a first step, nature would favor any changes that made the flat patch more cup-like.
As soon as you've created even the slightest depression in the center, it means that the edges of the cup will actually shade light from parts of the environment. And of course, all the light-sensitive cells in this little cup, they won't measure light in exactly the same direction. So already this cup has some pictorial information.
Another model demonstrates what a primitive cup eye can do. The brightly lighted skulls cast an image onto a translucent screen Nilsson installs at the back of the cup to act like a retina. But the image is not at all well defined. The cup eye can do little more than detect movement. This kind of eye can be found in nature today, in flatworms. Their eyes evolved no further. In their environment, that's all they needed.
But if the animals need to move faster or evolve to become fast predators or to see other fast predators, then the construction needs to be improved. And one way of doing that is to constrict the opening, to make it smaller.
That's just what happened to creatures like the chambered nautilus. Over thousands of generations, natural selection favored those with slightly more constricted eye openings, which focus light more sharply. This worked well, up to a point.
Since this strategy of making a sharp image also has the drawback of creating a very dim image, it's not very popular in the animal kingdom. And there is an alternative solution, which has become very popular in the animal kingdom, the solution that we use in our own eyes, and that is to put in a lens.
Nielsen's model lens uses 2 thin layers of clear plastic. He can inject water in between them to make the plastic windows bulge out like a convex lens. This mimics what natural selection might have done over a few 100,000 generations, favoring animals with a rounded, transparent layer in their eyes that cause light to be focused more sharply on the retina.
So we can make it gradually from no lens at all and just continue to inject more water, making the lenses bulge more and more, and the image becomes gradually sharper and sharper. So we can go all the way gradually in very small steps from a simple pigment cup eye, which has barely got the ability to determine the direction of a light source, all the way to a complete camera type eye of the same type as we have ourselves. And that is really exactly the way eye evolution must proceed.
The extreme complexity of the eye left Darwin in a cold sweat, he wrote to a friend. But still, he was convinced that an eye could be formed by natural selection. He later wrote that eyes must have evolved by numerous gradations from an imperfect and simple eye to one perfect and complex, with each grade being useful to its possessor. Nature, unaided by a designer, could produce an organ of seemingly miraculous complexity.
What a horrid smell.
Annie, come and look. When I first started looking, I thought lots of the barnacles had tiny parasites. That's an animal or plant that lives on another animal or plant, gets its food from it, like mistletoe on an apple tree. But they're not. Do you know what they are?
No.
They're little tiny husbands. The females carry little tiny males around with them, clinging to their skirt tails.
Just like you and Mama?
Just like me and Mama. I think it's the most interesting barnacle in the whole wide world. What do you think we should call it?
Barnabas.
Barney, for short.
Barney Ickle.
The tiny parasitic males are rudimentary in a way that I believe can hardly be equaled in the whole of the animal kingdom. They have no mouth or stomach. They are really little more than a tiny head atop an enormous coiled penis.
A bit like me, really. Apart from the bit about the mouth and the stomach.
What's funny?
Nothing! Nothing!
Charles! Charles, are you all right? Charles! Erasmus, take him home.
Why must you work so hard at your horrid little mollusks?
Oh. They're not horrid little mollusks. They're horrid little crustaceans. And I have horrid pigeons and horrid worms, too. They're providing the evidence I need for my theory. Oh. I don't have the right to publish the idea unless I have the evidence.
We must do something about you.
Your stomach condition is nervous in origin.
brought on as a result of excessive mental exertion.